Good afternoon, guys.
Good afternoon.
Yeah. Is your problem resolved, Vitiraj?
No, ma'am, same.
Still, you have the same issue?
Ma'am, instead com.DT, I have gave com.example what group ID I have created,
Okay.
but it is showing same problem. So yeah, I have to try with another means another
Can you clone that repository, whichever I have shared with you?
means I type the URL in Google and go to your GitHub repository and copy that form.xml and I put that form.xml file in my form.xml file.
Okay.
And then I do ambient clean.
So project executing. Have you checked whether the jar file is created or not?
Jar file is created, ma'am. Jar file is created. Demo.2-2.0.java is created.
Okay. But have you checked whether that is a recent jar file for your project or the one which you taken from my project?
That I have taken from your project.
Okay. But after MUN clean command, the jar and target folder is getting deleted. Am I right?
Okay.
Yeah.
So I have to execute that again that commands also.
Yeah. Once you copied your pom.xml file, then you have to execute all the command from mun clean. Okay. Mun clean, then mun compile, then mun package. Okay. Once you execute package, one more the previous target folder will get deleted and new target folder will be generated. Okay. The new target folder you will have a demo app. Something will be there. .jar file. Okay. Now what you have to do? You have to execute that jar file. So to execute that jar file, you have to provide code like Java. Let me write down somewhere.
You can type on the chat.
Yeah. Here I will type, okay? So what you have to do, in the target folder, you will get, after executing all command, you will get one target folder. And in the target folder, you will get some files. Some .class file will be there or some jar file will be there, okay? Some name will be there. Here I will mark it as a star instead of name. I don't know the name. That's why I'm writing it as a star.jar, okay? So to execute jar file, what you have to do, you have to first of all, write the command java-jar and then the jar file is residing into the target folder. So first of all, write target slash jar file name. Something will be there. Instead of this, I'm writing star.jar. Okay. This command you have to execute to check the output. Okay. If it is a jar file. Okay. Java-jar target slash star.jar. So this command will execute the jar file which is available in your system. Okay. So after executing, you will get some output, hello world or something, whatever it is there, you will get the output. Okay. Got it now? So first thing where you are,
Yes, I got it.
Or else, if you are not understanding this thing, this copy paste is not working, do simply create one folder, okay? Like demo name, something like that, new folder. Just enter to that folder, okay? And after this, after entering into that folder, what you have to do? You have to clone the repository which I have provided, okay? You have to clone the repository. After cloning, just check whether the same folder, whatever folder created after cloning, check whether the same folder contains XML file or not, form.xml file. If that folder have a file, then execute the all maven command. Okay. Then execute maven command. And after that, you can again execute this given command. Okay. Which one? Here, Java. Same command again you can execute here also. Understood? Two ways are there, okay? If copy paste is giving some error, then you can try this way. Okay, Dwitiraj?
Ma'am, I'm getting an interview call. Just one.
Sorry?
I'm getting an interview call. Hello.
Yeah, hello.
Ma'am, I've got a call from a recruiter, ma'am.
Okay, fine, no problem. You carry on. Yeah, so I think so we will stop here. We will start with the today's work. Anyone else have any doubt?
No, ma'am.
Yeah, Sushmita, have you tried?
Yes, ma'am.
It's executing for you?
No, ma'am. It is solved. I deployed in Tomcat.
Okay. So where you are getting error? While deploying in a Tomcat or while executing Maven commands?
No, ma'am. It was cleared already.
Okay, okay. You already deployed?
Yes.
Fine, fine. Good. No problem. Okay. So let's
Yeah.
start with today's new tool. So today we will start with our new tool, that is our DevOps. We will proceed with the DevOps new tool, that is the Docker. Okay. Now, main thing, what is a Docker and why we are using? That are the two important questions. First of all, before learning Docker, what is the Docker and why we are learning Docker? Okay. So mainly, if you remember that diagram, Docker Hub diagram, this tool is introduced when the developer completed his code development process. Okay. Whenever the code is ready, after that, Docker tool is introduced. Okay. So the main purpose of this Docker is to create a container. Okay. Now, what is this container? So the container is a, yeah, let me allow some more time to enter. Yeah. So we can say the container uh, is used to deploy, run, and to share your application. Okay. This container have everything which is required to execute your application. Okay. So whenever you developer have completed his code, he will hand over the code. Okay. That code will be used to create a Docker image. Now we will use this Docker image and we will store on some of the registry. From registry, we can fetch that image and we can execute that image. So whenever we are executing that image, the image will be converted into the container. Okay. Let me share you PPT for the clear view. My screen is visible, everyone?
Ma'am, which stream? Paint stream.
No, no, no. Let me share my PPT. Let me share once again.
Okay.
So let's move with the new tool. Okay. So we are going to learn Docker. Okay, this week we will focus mainly on the Docker. So in this we will see what is Docker, then what is the difference between Docker and virtual machines. Okay, what is a containerization and what is a virtualization? This is very important question. Many times this will be asked. What is a containerization and what is a virtualization? We will see in the next slide. How does Docker works? What are the components of a Docker, architecture of a Docker, then Docker client server architecture. Here in Swarm, we will see Docker client server architecture. Then Docker images. What is meant by Docker images? What is a Docker registry? Docker container, Docker compose, and Docker Swarm. These are the all concepts that we are going to see in this Docker tutorial. Okay. So why? Why Docker? Okay. The important thing is why Docker. So if you see, Docker will let you build, test, and deploy your application quickly. Okay. So what was the problem in earlier scenario? So usually whenever developer are creating some application, he used to number of languages are available. He used to select one of the language. Okay. Then that languages will be supporting for particular configurations. Okay. That language may support a particular framework. For example, Java is only supporting Spring Boot applications or Spring Boot framework, isn't it? So many types of languages and tools we need to configure with each other to create a single applications. Okay. And this configuration was becoming the tedious task. Whereas to build what we are exactly doing in a Docker, we are taking an application and to execute that application, whatever things required. For example, it can be a tools, it can be a binaries, it can be a plugins, it can be a packages, it can be an environment. Everything we are going to club together and we are going to form an image. Okay. What we are going to do in a Docker. So once the code is prepared, to execute that code, whatever things are required. For example, it can be a binaries, it can be a libraries, it can be a plugins, it can be a tools, supporting tools, or it can be some frameworks, it can be some softwares, it can be some frameworks, everything. Maybe it can be a runtime environment also. So everything, whatever things are required to execute that code, that all things we are going to club together, we are going to form a package. Now, if I want to tell a simple example, like in the last session, we have seen one Maven application. Okay. So what are the tools we have used there? We required a language as a Java. Okay, the framework which we have used are the quick start framework. Okay, Java framework we have used. Then Maven we have used as a build tool. Okay, and the platform we have used to execute application as a Java. Okay, JDK platform to execute that application. So here in a Docker image, what we are going to do, we are going to take all these things, okay, to run application, to execute that application, whatever all things are required, we are going to club together and we are going to form an image. Now this image contains everything. Okay, this image contains libraries, this image contains system tools, this image contains code, and this image contains runtime, everything. So language is also, a language platform is also added, binary is also added, whatever tools required to execute that project, that tools will be added. For example, Tomcat server. Now here in the previous example, we have separately installed Tomcat server. So if you remember, this is the code. Consider this is the code. Okay, this code required some library to execute this code. We required some tools. Okay, for example, Maven is one tool we can say. So to execute this code, I required Maven. Okay, next to deploy this code, what I required? I required one server. That is nothing but a Tomcat server. Okay, so if you see carefully, this is a Tomcat server. Okay, so if you see carefully, to run this single code of application, we required Maven, we required Tomcat, we required Java. Am I right? Java. Okay, Java language we required. Then to execute, we required platform as a JDK. Am I right? So to execute simple application, we required so many tools, so many libraries, so many dependencies, everything we required. So what we are going to do, in a Docker, with the help of Docker, everything will be kept together and everything will be together, will be called as an image. Okay. So everything we are going to bundle together and we are going to form an image. And this image will be stored on some registry. Now, what it mean by registry? Okay, this image will be stored on the registry. Now, next time when anyone want to run this code, instead of installing Maven on your system, instead of installing Tomcat on your system, what we will do, simply we will fetch this image from the registry and we will execute the registry. We will execute the registry. Now, what if I already have a code and I want only Maven? In that scenario, Maven image is already available in the registry. You can drag that Maven image and you can run for your application. Okay. So here, with a clear understanding, you see carefully, guys. Okay. Am I audible, guys?
Yes, ma'am.
Yeah, I think so. I was not getting any response from your side. Okay, fine. Now see. So what I was trying to tell you that, so a image isn't nothing but a template. Okay, image, it is a template which is used to create, build and share your application. Okay, it is used to test, build and deploy your application quickly. Okay, so if you see, Docker is a software package and which has a container. Now what is the container? So as I told you, we will create one image. Okay, here with the help of Docker we will create one image, and then to this image it will form into container. Okay, whenever we are executing this image, or whenever we are run this image, it will create a container of that image. Okay, whenever we are so we have created image for a particular application. Now this image has everything. It have a tools, it have a libraries, it have a code, it have a runtime environment, everything we have bundled together and we form a image. Okay, now whenever we are running this image, we are executing this image. Told you what it mean by it can run on any environment. See, now already I have Maven in this. Already I have a Tomcat server in this. So even though if I use Windows operating system, it will not affect on because of the operating system. Why? Because all the things required to run this application we have together in this image only. So we can run this image on any platform, on any OS. Why? Because it is providing lightweight isolation. It is providing lightweight isolation. What it mean by isolation? That this image will not bother about the platform or the OS which we are using. Why? Because to run this code or to run this application, whatever things required, all the things we have packed together, we have bundled together as a single image. And now just we have to run this image to execute that application. Okay, from a single image, we can create number of container and we can run all uh, how we will build this, how we will create this application. So with the help of a container, okay, with the help of container. So it will allow developer system admins to easily develop their application in a containers to run on the host operating system. As I told you, the host operating system, the underlying host operating system will not affect on these containers or on this image. So is it similar to virtualization? Then question arises that, see, we are creating containers and everything required to execute that images, execute container, we have a inbuilt image. Okay. So now can you tell me?
Hello, ma'am. What exactly things an image contains?
Sorry, your voice is not audible.
Yeah, what exactly things a image should contain?
Yeah. So exactly now, if you consider a simple Java application, okay, that we have taken in the last session. Okay. So what the Java applications required? It required first about Java language. Am I right? Java should be installed on your OS. Am I right? To create Java application, Java should be installed on your OS.
Yes, ma'am.
Yeah. Then next, what we have used? We have used a Maven build tool. Am I right? To create that project, the demo project, what we have used? We have used Java as a language, Maven as a build tool. Yes, am I right? Then we have used a quick start as an archetype. Am I right? Quick start as an archetype. In Maven also we have multiple archetype. Do you remember that? Web app
Yes.
we
Web
have a,
app, yes.
yeah, right. Then Spring Boot archetype we have a, among
The
that we have,
React.js archetype we have.
correct. So among that what we have chosen, quick start archetype we have chosen. Am I right? Okay. And now we have created application. To execute this application, what we required? we required JDK. Am I right? Java runtime environment we required. Am I right? To execute that application, Java path need to be set. Am I right? So Java runtime environment, JR is required to execute this application. Plus, to deploy this application or code on the server, which server we have used? Tomcat server we have used. Am I right? So now you tell me, to run this simple project, what things need to be installed on your system? Tomcat should be installed, Java should be installed, Maven should be installed, JRE should be installed. These all things should be installed on your system. Then and then only you can run this application. Am I right? So what we will do, instead of installing everything. Why? Because maybe my system is not supporting to install Tomcat. Maybe my system is not supporting to install Maven. In this scenario, what we will do? Again, to install these things, we need to configure the things also. We need to configure the path variable for Java and Maven. So we need to do a lot of work. We need to first install this all softwares. We need to configure. We need to set the path. Everything we need to do, and everything will be done on the host operating system. Am I right? So it is creating a lot of burden. So instead of what I will do, I will create an image of my application. And while creating image, what I will do, in that image, I will add Java, Maven, Tomcat, JRE, everything I will add plus code, plus actual code. I will add everything. I will bundle it together and I will form it as a image, single image. Now, if you want to run the code, simply you have to run this image. For you, no need to install Java, Maven, Tomcat, anything. For you, no need to install. You just have to run this application, you have to run this image only. Because this image itself contains everything. Okay? Image contains everything. Now, whenever we are executing this image, that image will become as a container. Whenever we are executing that image will become a container now. Okay? Executing image will be called as a container. Why it is called as a container? Because it contains everything. Okay? To run that image, whatever we require, it contains everything. Okay? So we will take one Hello World application whose image is already available into the registry. Now, what is a registry? It is a repository. Okay. We have a Docker registry. So what this Docker registry? It contains all the images which are previously created. For example, if you don't have Ubuntu system, am I right? Many of you don't have Ubuntu system. You are still working on a Windows system. Am I right? So in Docker registry, we have a Ubuntu image. We have a Ubuntu image. Now, what you can do with this Ubuntu image? So to use Ubuntu operating system, what you have to do? You have to run this Ubuntu image and then you will get Ubuntu OS as it is for your use. So no need to install this Ubuntu on your system. If you don't have Ubuntu image, what you can do? You can use this Ubuntu image and you can do all tasks whatever you want. Okay. So if you don't have Ubuntu image, what you can do? You can use this Ubuntu image. Okay. And then you can install whatever you want. Whatever software you want, you can install on this Ubuntu image. You can run application. You can try some Linux command also if you want. So simply to work with the Ubuntu, what you have to do? You have to pull the image from the registry and you have to run the image. Okay. So whenever you are running this image, it will become a container. Okay. It will become a container. Now understood? So let's see again more detail in the next slide. So what exactly Docker is? So it is a platform which enable user to develop, ship, and the run application with ease. Okay, without any hassle. So this container have all the elements. What the container it have? It have a system tools, libraries, and runtime environment. As I told you, okay, whatever tools like a Java, Maven, these tools will be there. Then libraries, whatever Java libraries are there. Then templates, for example, quick start template we are using in Maven. Then runtime environment is a JRE. So whatever required by the software, all the things will be bundled together into a image. And whenever we are executing image, it will become a container. Okay. So as I told you, container is a very lightweight package which contains all instruction and the dependencies such as the framework, libraries, and binaries within it. Okay. Now, next we will see what is a container. Okay. So we can say container is a standard unit or software package which contain all the dependency of the application to run the application quickly and reliably. Okay. So when the container will be created. Now, if you see, I have a one image. Okay. Consider I have one application which is printing hello world. Okay. I have one Java application which is printing hello world. Now, for that application, I have created one image. Okay. For that application, I have created one image. So this is the hello world image. Now, whenever we are executing this image, whenever we are running this image, it will become a container. Okay. So remember, when the container will be created, whenever we are executing the image, that time it will become a container. So it will become a container. Okay. So what are the some features of a container? Containers are lightweight. Okay. So what is mean by lightweight? That it does not require any separate OS. Whatever your underlying OS is there, maybe Windows or Ubuntu, whatever OS is there, it will run on that OS itself. Okay. It does not require a separate OS. So it uses host OS system. It starts quickly. It needs less hardware resources, and it also shares the kernel of your operating system. Okay. So Docker container does not require any separate OS. It uses your host system OS. Also, these are the lightweight. So it starts quickly and it requires less RAM. We can say less size of the container is very less. So it requires less hardware support as well as software support, and it uses the same kernel of your OS. Okay. So main the
But
difference.
madam, what do you mean by dependencies? This suppose if we use a code, okay, then
Yeah.
what is the dependency of that code?
Okay. Fine. So dependency are the module or the packages. Okay. These are also jar files. Dependencies are also jar files. So if you have seen the Java code, in the Java code, what we have you seen something like a import java.io? Do you remember something? Have you seen? So import in the starting of your Java, you will see import Java. Let me show you better. If you haven't seen, let me show you the code for the Java libraries. Okay, let me let me paste it here somewhere. My screen is visible. Are you able to see my screen?
It is showing that container PPT. What is the container PPT?
Okay, fine. Let me share by code. Okay. Yeah. So libraries or dependency, okay, you can call it as a dependency. So dependency are the libraries, okay. So what it means by library here, these are the jar files, okay, which are pre-written or which is already written as a supporting, okay. For example, if you see the Java library in Java, to execute your Java application, you are writing public static void main. So do you know the meaning of public static void main? We know, but how the system will understand what is the meaning of public static void main? Okay, so for this public static void main, in background some code is already stored. The meaning of each and every word, the code for that word is already written in some modules or some libraries. That library are stored as a packages. While installing these packages will be installed whenever you are installing Java, these all packages or we can say libraries will be installed along with your Java. And these packages or libraries contain the code which is required to understand the predefined words in your language. Okay. For example, if you are using public static void main, how the system will understand what is the meaning of print? How the system will understand what is the meaning of print? We know what is the meaning of a print, but how the computer will understand what is the meaning of a print? So to make system understand, we have a pre-written course or pre-written modules. Okay. So this module will help a system or computer to understand the meaning of your print statement. Okay. So whenever you are installing a Java tool or the Maven tool, whatever all inbuilt packages are there, that will be installed along with your application, along with your tool. Okay. Now, whenever you are you are printing or you are writing public static void main, it will import the package. Okay, whatever installed package is there, supporting package, we will import that package, and with the help of that package, a system or the your program will understood the meaning of each and every word. Okay, so in general, we can say dependencies are some pre-written jar files. Okay, pre-written jar file for that particular tool or application. So in Java, we have a system.util. Then we have a, my screen is, are you able to see my screen?
It's fine.
Yeah. So you can see now math. So what is the meaning of this plus minus sign minus multiplication? How it will understand the meaning of each and every symbol? Whenever you are writing some program, how the system will understand the meaning of that particular symbol? So to make the system understand, we have some inbuilt libraries or the packages or the modules. Okay. So these libraries are created whenever they are creating this language. At time these packages are created, these libraries are created, and these libraries will be installed in your system whenever you are installing that tool or that application. Okay. Now, for example, for unit testing, we are using JUnit. So we can say how the system will understand this about JUnit. So the JUnit will be uh, uh, JUnit is also one of the library. Okay. If you remember in the Maven, we have used this JUnit library. So why we are using the JUnit library? For the testing purpose. Am I right? So we are providing this library to do the testing, to perform the unit testing. We are providing this library in terms of a jar file. Okay, in terms of a jar file. So by using this library, your program will able to perform unit test. You are able to understand the word or the whatever things written in that unit testing, like meaning of run or meaning of we can say meaning of debug. Everything will be understand with the help of a pre-written library. Okay. So in simple word, you can understand something like that. Dependency or the libraries are the pre-written jar files. Okay. Pre-written jar files. These pre-written jar files are required to understand the things whatever you are written in your application. Okay. For example, in your application, you are writing the print statement. How the system will understand the meaning of print statement? As a human, we know print means writing something. But how the system will understand? So to make system understand, we need this library where the meaning of this print and everything will be already written. That's why it is called as a pre-written library. Okay. So some are the standard libraries, some are the user generated library, okay, user defined libraries. Standard libraries are come whenever you are installing the software, that time standard libraries will be downloaded or installed in your system. And there some are user defined libraries, okay. So you can develop your own library and you can publish also. So whenever we are calling it as an open source language, open source tool, what is mean by open source tool? So what is mean by open source? Open source,
Means it is completely free, anyone can use.
yeah. But open source tool means source code of that tool is also available. It is freely available. One thing is there. Other thing is that the source code of that language is freely available. Have you heard somewhere Ubuntu source code is available? Ubuntu OS source code is available. Do you know? Python source code is available. Now here you can, what you can do, you know, not we actually, but some people who are interested while developing the language. Okay, Python, someone have developed Python, isn't it? Java, someone have developed the Java. So now if we want to contribute in that development process, what we can do, we can create our own library. Okay, we can create our own library and we can provide that library on the internet. Okay, it is like a user defined library. Now next time if someone wants some sort of a support, they can refer that library, they can import that library in their program. Okay, so they can use that library in the future. That's why it is called as a user defined library. And when a particular OS, we can say, or language is an open source, it is freely available is one term. Other term is that source code of that language is also freely available. You can check that source code, you can modify that source code, you can update that source code, and you can contribute into that source code. That's the reason it is called as an open source language. Okay, open source tool. This is also one more aspect. Now, see, I told you now how it will understand the plus minus, the symbol of this star, symbol of minus, symbol of plus, how it will understand. So for that, we have a java.math. This is one called as a library or the dependency, java.math. So if you want to execute any math related program, you require this library or the dependency. Why? Because whatever mathematical arithmetic operation you are going to perform, system should understand about that mathematical operation. How he will understand, how the system will understand about the multiplication, subtraction, how the system will understand. So to make understand, we have to provide the supporting library. So we need to import java.math into your program. Okay, while writing any arithmetic operation, what we have to do, we have to import this library. Now, where this library will be available? So as I told you, standard library will be available whenever you are downloading that software or downloading that package. So whenever you are downloading that software, at that time, all the standard library will be get automatically downloaded in your system. Simply you have to import it and you have to use it. Now, when I'm telling that Java language or java.util. So these libraries are helpful to understand the meaning of public static void main, then system.out.println. To understand the meaning of these words, these libraries are required. So whenever we are writing program, first of all, we need to import this library and then we can start writing our code. Okay. Now understood meaning of dependency in libraries?
Yes, madam. Understood. Thank you.
Yeah. Fine. So let's proceed with the next. Here we are, Docker. Okay, so container. So understood your container, we will create an image and when we run that image, it will become a container. Okay. Now, as I told you, we are including everything into that image. For example, we are adding dependency libraries, tools, runtime support. Then what is the difference between virtualization and the containerization? Am I right? So before understanding these things, we need to understand what is the container and what is a virtual machine. Okay. So if you see this diagram carefully, What happened to this? Let's save this file. So if you see this diagram carefully, here we have two things, okay? One is a Docker container and other one is a virtual machine. So here in the first diagram, if you see, we have a infrastructure. Infrastructure is nothing but your physical system, okay, which contains your hardware and the software. Above that physical system, we have a hypervisor. Okay, what is meant by hypervisor? Can anyone know? Do you have idea of hypervisor? You might have heard about virtual machines. So, are you using EC2 instance? Are you using EC2 instance? So, what is this EC2 instance? Are you providing any hardware support for that EC2 instance? Anyone? Are you providing any hard disk to that EC2 instance? Are you providing any RAM chip to that EC2 instance? Are you providing any other keyboard or any other supporting devices, hardware devices or the software devices? Anything? Are you providing anything to that virtual machine?
No, ma'am.
Are you able to get my voice?
Yes,
Yes,
ma'am.
yes, ma'am.
Yes, ma'am.
Yeah. So simple, but you might have worked out with the EC2 instance. Do you remember? So EC2 instance, if you see, everyone is calling as a virtual machine. EC2 instance, we are calling as a virtual machine. Why it is called as a virtual machine? Anyone? Any idea? So why it is calling virtual machine? Because we are not providing any hardware support to these machines. Okay, we are not providing any hard disk. We are not providing any RAM chip. Am I right? We are not providing any input output related devices. Okay, we are not providing any CPU. So from where EC2 instance is getting all these things? From where this EC2 instance is getting all these things? From where it is getting hardware support? From where it is getting software support? What about CPU? Which CPU is EC2 instance using? And from where this CPU is taking? So we can say why? Because this is called as a virtual machine, and this virtual machine is based on some physical machine. Okay. This is EC2 instance is an virtual machine, and this virtual machine is based on some physical machine. Now this physical machine is nothing but your data center or some servers. Okay. These server are managed by your Amazon or maybe Azure or maybe Amazon or the Microsoft. Okay. Who is managing this physical servers? So physical servers are managed by either Microsoft for Azure and Amazon for AWS. So these physical servers are managed by these people, and based on these physical servers, we are creating these virtual machines. Okay, these are the virtual machines. All instances, whatever we are creating in EC2, Azure, all these instances will be called as a virtual machine. So in simple word, we can say virtual machines are the independent systems, but it shares the same physical IT infrastructure and managed by the hypervisor. Now, who will help us to create these virtual machines? So there is one abstraction layer which is called as an hypervisor. Okay. Above your physical machine, there is one abstraction layer. It is also software. Hypervisor is also software, you can say in simple word. Okay. So this is a software hypervisor. Okay, we will call it as a one more layer. Okay, so this is an abstraction layer hypervisor, and what it will do, it will help us to create a multiple virtual machines from a single server. So this is a physical server, and based on this physical server, with the help of hypervisor, we are creating multiple virtual machines. Now Each virtual machine have its own OS. You can see here. Each virtual machine have its own OS. It have its own file structure. It has its own applications. Okay. This virtual machine will mimic like a actual physical machine. Okay. This virtual machine will mimic like an actual physical machine. It will have your we can say it will have its RAM, it will have its storage or hard disk, it will have its CPU, everything it will have. But these things are taken from your physical server or physical machine. Okay. And who will help us to create these virtual machines? That is nothing but hypervisor. That is nothing but hypervisor. Okay. So hypervisor, we can say it is a software that creates and runs virtual machine. Okay. So we can say a hypervisor will allow one host computer. We can say one host computer to support multiple virtual machine, and that virtual machine will be called as a guest virtual machine. That virtual machines are called as a guest virtual machine, and they are sharing resources from the same physical machine. Okay. So whatever resources available here in the physical machine, that resources will be shared among these virtual machines. Okay. Now again, I will explain you. Listen carefully. Okay. So if you see, we have a EC2 instance. Okay. So what is this EC2 instance? We will call it as a virtual machine. Okay. Why we will call it as a virtual machine? Because it doesn't have any hardware and software requirement. Okay. So how these virtual machines are created? These virtual machines are created with the help of a hypervisor. Okay. With the help of a hypervisor. Now, what is this hypervisor? So we can say hypervisor are also software which help us to create and manage the virtual machines. Now, here we have a actual or physical machine, okay, or we can say physical server. This is your actual physical server, okay. So it have everything, hardware as well as software infrastructure. It have a hardware as well as software infrastructure. So based on this physical machine, we can create multiple virtual machines. We can create multiple virtual machines, but all these virtual machines share the resources from the physical system only. Okay, from where these resources will take? From the all these virtual machine will take the resources all from the physical machine. This is the physical machines, and all resources whatever we are using in this virtual machine, all resources taken only from this physical machine. Okay. So who will manage this virtual machines? A hypervisor. Okay. So if you see, this is the virtualization concept. If you see carefully, this is a virtualization concept where this is an physical machine. Based on this physical machine, we have created 3 virtual machines. These are the 3 virtual machines, 1, 2, 3. Okay. So each machine will have its own guest OS, it have own file structure, and it have own application. So each virtual machine will act like an individual operating system, or it will mimic the actual operating system. Okay. So we can say as this virtual machine have its own OS, or we can say it has its own guest OS. So it is a fully isolated from your host. This machine or this virtual machine is fully isolated from your host machine. What it mean by fully isolated? So if I install any software on this virtual machine, if I install any software on this virtual machine, that software will be available only for particular that machine. It will not affect or it will not install on the underlying physical server or physical machine. Okay. If I install another software on this second virtual machine, so it will be affected only to the second virtual machine. It will not affect on the first virtual machine or the third virtual machine or the underlying physical machine. Okay, it will reflected or it will affect only for that particular virtual machine. That's why it is called as a fully isolated. Okay, it is called as a fully isolated. So this is the concept of a virtual machine. Now let's move towards the container concept. Okay, so it is also called as a containerization. The process of creating content is called as a containerization, whereas A process of creating virtual machine is called as a virtualization. This is a very important question. What is a virtualization and what is a containerization and what is the difference between these two? Okay. Many times in the interview, this question will be there. So now next we will move towards container. So what is a container? We know. Okay. Now let's see the concept of containerization. See, now here we have a host infrastructure as well as host OS, and on the host OS we will install the Docker application. Okay, we will install the Docker application now. Once we install the Docker application, what it will create, with the help of this Docker application, we can create the multiple containers. We can create the multiple containers. Now, these containers are isolated from the each other. These containers are isolated from the each other, but they are sharing same OS and same resources from your host machine. Okay, as I'm telling you, here you have a host machine. Okay, so this container will use the same OS of your host. Okay, container doesn't have a separate OS. Container doesn't have a separate OS, as virtual machine will have its own OS, whereas container doesn't have a separate OS. It will share the same OS of your host machine. Okay, so these are called as a lightweight. We can say lightweight isolation. This is called as a lightweight isolation. The main difference is that this is called as a lightweight isolation. This is called as a fully isolation, because each virtual machine will have its own OS, whereas container shares the host OS. Container doesn't have their separate OS. But each container is isolated from each other. That's why it is called as a lightweight OS. Just note down this point, guys. You can mention it as the difference between these two, containerization and virtualization. Okay. So you can see in virtualization, it will enable to run multiple OS on a single physical server. Here we are running multiple OS on a single physical server, whereas in containerization, it will enable us to deploy multiple applications using the same OS. Here we are deploying multiple applications using the same OS, and it will act as a single container or a single application. Okay, that means one container will not affect on the other container. Okay, so here process of partitioning physical server into multiple virtual server will called as a virtualization, and here creation of container will be called as a containerization. Okay, so here multiple containers will be available, and this container won't affect on each other, but they share the host OS operating system. Okay, host OS, they will share the host OS. Sorry. So each container will have their own application code, libraries, configuration file, dependency, everything, whatever required to run that application, cross-platform, everything will be added or included into the container. Okay. So that is the main difference between container and the virtualization. I think so I have mentioned in the next slide.
So madam, if we install any, suppose XYZ software on container P or container C, then will it be installed on host operating system as well, if that host operating system is shared with all application servers like B and C?
Yeah. So first of all, see, in container, we are not installing any application. For that application itself, we are creating container. A container is nothing but a representation of an application. Here we are installing application on the virtual machine, but here for particular application, we are creating container, and that container will share the host OS. It doesn't have its own OS. Now see, if you want to execute or create one application, you can create container for that application and you can run that container. You can run that container, you can execute that container. So here no need to install anything. So to execute container, we require underlying OS. Am I right? To run that container, to run that application, we required OS, and that OS will be shared from your physical system or physical server. So here we are not installing anything actually. We are creating the application or we are creating the container and then we are running that container. And to run that container, it is using host OS. Whereas in virtualization, what we are doing, we are installing separate software. Okay. And that software will be particularly installed on that virtual machine. It will not affect on the underlying physical machine. Okay.
Oh, clear. Thank you.
Yeah. So next we will move to the next slide. So even though whenever we are practicing all the things, I know theoretical parts will be quite confusing. Why I am adding this PPT? Because up to the last batch, I have not added any PPT. Then what I realized, people are facing issue while giving the answer. Okay. As whenever you are going as a fresher, they will ask you theoretical type question like what is the virtualization, what is the containerization, what is the difference, what is a Docker, what is a container. So as a fresher, people will find difficult to answer such a type of question. That's the reason this time I have introduced the PPT. Okay. So next time, whenever you are preparing for the interview, you can simply refer this PPT and you can give the answers. Okay. Yeah. So next up, what is containerization and virtualization? Here difference is mentioned. You can refer later. Okay. Size of a virtual machine will be in GB, whereas size of a container will be very less. Okay. It will be something in MB only. A container size will be very less. So yeah, here it is mentioned, you can see. So containers are taking space in MB, whereas if you create virtual machine, it is taking size in a GB. Okay. So here some difference is mentioned, you can refer later for understanding purpose. Okay. Next, we will see the Docker demo. Okay. So let's see the architecture first. So the main Docker architecture is divided into three parts. We have a client, we have a Docker host, and we have a registry. Now, what is meant by this registry? So this registry is nothing but your repository. Okay. Now, what is meant by repository? As I told you in the earlier session, do you remember repository is nothing but to store your content. Okay. Repository is nothing but to store some content. So what this repository will have, it will have a different images. Okay. It will have a different images. Now someone have already created images and they have uploaded that images onto this Docker Hub registry. Okay. Someone have already created. For example, for Tomcat server, they have already created one image. For Nginx server, there is already one image available. For Ubuntu server, there is already one image available. Now to print hello world, so for this application, for hello world application, there is already one image is available. Okay. So like that, there are already multiple images are available on this Docker Hub registry. So I can say it is a repository or it is a hub which contains different types of images. Now, what types of images are there and how this registry look, I will show you in the next slide. Okay. So this is a repository which contains almost all types of images. Okay. Now, whenever required, we can refer that images. We can run that images. We can make it as a container and we can start working on that container. Okay. So this is the registry. Then client. So whenever you are installing Docker, by default client and the Docker daemon will be installed on your system. Okay. So Docker is an application, is a tool. We can say Docker is a tool. So whenever you are installing this tool, by default client and the Docker host, or we can say Docker daemon will be available in your system. Okay. So what this client will do, this client will execute the command. Okay. What type of command it will execute? So build command, pull command, push command, run command. Okay. This command we are executing on the client side. Whenever you are executing this command on a client side, requests will go to the Docker daemon. Okay. So the communication between client and Docker host will be carried out with the help of API Okay, API is the communication way. Okay, we can say these two, client and the Docker daemon, communicate with each other through the API. Okay, API is the application program interface. Okay, so it is an interface which is used for communication between the client and this Docker daemon. Okay, so what this Docker daemon contains, the actual task of Docker daemon to run the images. Okay, to run the image. So command will be given from the client, and after getting command from the client, Docker daemon will execute the image. So whenever we are executing image, it will create a container for that image. Whenever we are executing image, it will create a container for that image. Okay, so the architecture is divided mainly into three parts: client, host, and the Docker daemon. Okay. So is there any doubt in this? So now a client, here if you see, we have a command like a pull. What is mean by this command? So whenever you want to use any image from this registry, what we will do, simply we will pull that image from this registry. So if you remember Git and GitHub, what we are doing, to clone the repository or to synchronize the repository, we are using git pull command. Am I right? To get the changes from your remote repository, what we are using, git pull command. What git pull command will do, so whatever changes or updates are there in the repository, that updates we are taking on your local system with the help of git pull command. Am I right? So here also in Docker, we have a pull and push command. Okay. So to get the image from the registry, we are using pull command, and to push the image, if we have created image for our application, we need to store that image somewhere. Am I right? So that maybe production team or QA team can use that image. So to move that image to the registry, we have a push command. Okay. So here also we have a push and pull command. For example, if you are working in an organization and you created one application. Okay. Now you want to share that application. As I told you, main task or main purpose of Docker is to main task of Docker is to build, share, and deploy. Okay. What is the Docker? If someone asks you, you can add in these things in a definition that Docker is a tool which is used to build, share, and the deploy application. To deploy application. Now, what is meant by build? Creating image. Share means sharing with your Docker Hub registry. Okay. So if you upload on the Docker Hub registry, some other people or some other team member can fetch that image from the registry. Okay. If you push that image on the Docker Hub, simply if you push that image for your application, okay, you have packed that image, you have packed your application as an image. Then next, what you will do to share with someone, you will push that image onto the Docker Hub registry. And someone, when he interested into that image, what he will do, he will simply pull that image from your registry. Like that, you can do the sharing task. Okay, like that, you can do the sharing task. Okay, and next, deploy. Now, the same image can be deployed on any environment. Okay, so simply, if whenever you are creating environment, it will be the development environment. Am I right? So we will create the image and we will deploy into the Docker Hub registry. And while deploying that application into the production environment, simply we will take that image. So here on the production environment, for us, no need to install anything, no need to install any underlying software. As everything we have installed, we have added into that image. So simply we can pull that image and we can run that image. So we should not bother what is the production environment, what OS used in the production environment, and what software we need to install in the production environment. We should not bother about anything. Why? Because while creating image, we have added everything. We have added runtime environment, we have added supporting tools, everything we have added while creating that image. So directly you can deploy that image or you can run that image into the production environment. So no need to do any setup or any pre-configuration into the production environment. Okay. That is the main purpose we can say of a Docker. So, yeah, clear this Docker architecture, everyone. This is also important question. Write down second important question. What are the components of a Docker? This is also very important question. What are the components of a Docker? So let's see real-time scenarios. Let me do some real-time examples to you. So, fine. So fine. So this is a simple thing where I have tried to explain. So what is the difference between image and container? So image will be created, and when you are executing that image, it will become a container. Okay. So you can create container, you can stop container, you can delete container, you can create container. So these are some commands available into the Docker. We will see how we can run that command, but this is the main difference. Okay, image will be the builder, and whenever you are run that image, it will become a container. Okay. Yeah, then Docker networking we will see later. First of all, we will work with the basic images. First, try to understand how we can pull, push images, how we can use that images. Later, we will go in a detail about Docker network, Docker volume, how we can provide storage to that Docker container. So everything we will see in a detail. First of all, we will see the basic commands. Okay, let me share my screen. We will see first of all installation part. Okay. Why? Because many people are taking for installation. So we will first see installation part. I'm opening my AC2 instance. Wait a minute. Um, So I will share one website. You can refer for the installation. Just check your chat box. Docker installation is a very easy. So I will prefer to install on EC2 instance. So let me share you. Check your chat box for a link. The same link I have referred. Okay, I have shared link in a chat box. You can refer the same link for the installation purpose. Okay. Meanwhile, let me show you Docker registry also. Yeah, this is the Docker of registry. You can log into it. You need to provide only your username and password. So I will follow the same link which I have shown you, which I have shared with you also. I think so. So same steps I will follow for installation purpose. Okay. So while installing, there are two way, either from the official repository or from the default Ubuntu repository. So we will go with the official repository so that we can get the latest version. Okay. So first of all, we need to update the package sudo apt update. Okay. Here it will install, it will update all default packages. Okay. So now before installing this Docker, we need to install again few prerequisite packages. So this will help us to install prerequisite packages. Then we have to add security key to authenticate the package. So whatever package we are downloading, we need to authenticate that package. So for that purpose, we require a key. You can create EC2 instance and then you install. Okay. If you try to install all the software on your system, whatever you are using, it will actually it will slow down your system. So better you create EC2 instance and you start working here. Okay. After practicing, you can delete that instance. So I'm not doing anything. Whatever steps mentioned here, I am following that all steps. We also do the same thing for installation purpose. If you are using Windows system, you will get the Docker desktop package. Okay. So it will provide you CLI. You can execute all Docker related command on that CLI. Okay. How you are getting Git bash for Git tool. The same way you will get the Docker CLI whenever you are installing the Docker desktop for your Windows operating system. If you have Ubuntu or Linux, you can follow the same step which I am doing. Now, once installation, you can check the Docker version. So how we can check? We have a command sudo docker ---- version. Okay, you can check whether Docker is installed properly or not. You can see Docker version 24.0.6. Okay, and build success. That means Docker is successfully installed. You can see here. Now again, you can check the Docker info to get the detailed information about the Docker. Okay, what it is providing, so client and the Docker engine, then version, debug mode, plugins, so what plugins are used, then Docker Compose. You can see Docker Compose is also very important concept. It is also one of the plugin. So these two plugins are by default installed with the Docker. Okay. Then next, yeah, right now. So how we can check? Do we have any images right now with us? So for that, we have a command like a sudo docker and images. So whatever images we have in our system right now, we need to check that. So for that purpose, we can use docker images command. Okay. So if you see, these are the headings. We can say repository, tag, image ID, create and site. So right now we don't have any image in my system. So let's try pull some image from the Docker Hub registry. Okay. So this is a Docker Hub registry. I forgot about the password here. Please everyone register to this Docker Hub registry. I think so. I need to do the forgot password and all the things. Later I will check it. Let's leave it about. I remember one of the image. Okay. The basic image is to hello world. Okay. So I will pull that image. Okay. I remember the name of the image from the Docker Hub registry. So the basic image I will pull sudo docker pull and the image name is hello world. Okay. Hello. It is like the same every time whenever you are whenever you are installing any language, first of all, we are running hello world program. The same way here we will pull the hello world image. Okay. So you can see here, it is pulling the library and the message digest is generated and the image will be downloaded here. So now let's check whether the image is actually downloaded or not. Sudo docker and the images. To check images in your system, we can use sudo docker and images. Okay. You can see. So this is the name of the image, hello world. The tag of the image is the latest tag is nothing but version. Okay. Then image ID. Then time when the image is created. This time is not synchronized, so don't bother about it. And the size of that image. Okay. Now I told you this is the image. This is not a container. When I run this image, it will become a container. Okay. Now what this image is contained. So right now we don't know anything about this image. Okay. Let's try to run this image and check the output of this image. So how we can run this image? So docker. I need to provide sudo because I don't have a root permission here for a docker. Sudo docker run and the name of the image. What is the name of the image? Hello world. Okay. Either you can provide the image ID or the image name. Anything is okay. So see, this is the output of this image. Hello from Docker. Hello from Docker. This is the output of the image. You can see. Okay. Right. Like this. Maybe this hello world image also contains Java and the Maven project and all this command. But here directly we can able to check the output of this image. Okay. Hello world. So how we can create image, how to work with other image, we will see in the tomorrow session in a detail. I will log into the Docker Hub registry to show you more images and what exactly that image contains. Okay. And how we can create our own image, that also I will show you. But we will see in the tomorrow's class. Okay.
Okay.
Madam, I have few doubts. So here this 172.31.19.29 is Docker host, right? As per our diagram.
Sorry.
This Ubuntu machine 172.31.19.29 is Docker host, right?
Yeah, right now, whenever I'm installing Docker on the Ubuntu, by default, we will get a Docker client and Docker daemon. That means Docker host and Docker client will be installed on the same system.
Same system is this Ubuntu system.
Yeah, same system is Ubuntu system. On the Ubuntu system, Docker host and Docker client, both the things installed at the same time.
And we cannot create a image for Windows, right? In virtual machine, we create a Windows virtual machine. So in this container concept, we can't create a application like a Windows machine, right? Means if
We
Windows
can create
image.
no problem.
Oh, okay.
We can create any image. For Windows OS also we can create image, no problem.
Oh, okay, ma'am. Understood. Thank you.
Fine. So we will see how to create images and how to work with the images. We will see how to work with the container. We will see in the tomorrow's session. Meanwhile, those who are new members, I got the message from the duty to get your phone numbers and IDs, mail ID for further communication, I guess. So can you provide the details in the chat box? Those who are new members. I think so. All are the already new members.
Ma'am,
Yeah, tell me.
ma'am, is there any chance that you can connect with me on personal note?
Yeah, you want to discuss with me or with the team?
No, ma'am, with you about DevOps only. Nothing personal, but because of my health, I get missed out in few days. So I want you
Okay.
to help me somewhere. So not
Yeah,
like
sure. That's not a
because
problem.
here everybody will get disturbed. So I want you to connect with me personally. Is it possible?
Yeah, sure. We will schedule a session as per our both convenient time, so that we
Okay.
can resolve your doubts. Okay, or your queries, whatever it is.
Ma'am, but I don't have your number.
Sure. I will share my number with you.
Okay, ma'am.
Just give me your number in a chat box.
Sure, ma'am.
Yeah. I will send you my details. Are you there in the Slack?
No, ma'am.
You better you join Slack group. You can directly text me there.
Okay. Actually, ma'am, it is having some this issue. Mail.
Mail.
Ma'am, I send my number in the chat box. Can you see?
Okay, I'm checking. Yeah, got it.
Okay. I just want a few hours, ma'am. Whenever you are available.
Okay, fine, no problem.
Okay. Thank you.
Okay, yeah. Meanwhile, you just join the Slack group also, because any doubt or anything, you can text me there also, no problem.
Sure, ma'am.
Will I ask you to send you Slack link?
Yes, ma'am. Actually, my mail ID is having some issue. It is not getting registered. I'm not getting OTP. But I will go through some different ID, ma'am. I'll
Yeah,
join that.
why? Because we will create one group for a DevOps discussion, okay? So where I can post some interview related questions and some other details, some reference website will be there that you can refer. This is for everyone actually, not for you. But but everyone listen. So you can join that group. So there I can post some discussion. What are the current trends in DevOps? What are the new functionality added into the Jenkins, Docker? What are the trending tool? That all the things we can discuss in that group. So better you join that group, and we will have the regular communication. Okay. So fine, everyone. See you tomorrow. Bye. Have a nice day.
Same to you, ma'am.